Hello everyone, welcome to the course Hydrology EVE 301 offered to civil engineering students during 5th semester. I'm Kirtan Adhikari, faculty at College of Science and Technology, Royal University of Bhutan. Hello students, welcome back. So we'll continue our lecture. So I was explaining you about the midsection and the mean section method. So this is the midsection method, okay? So in this method, what we normally do is as you can see, the cross section is, we divide the cross section into various section, and this heights are the chosen height where the velocity measurements are recorded. So this red dot, as you can see here, are the location, normally 0.6 0.2d and 0.8d. This is 2-point measurement method. So in this vertical, the vertical d5, for example, there are two measurements taken at 0.2d and 0.8d. And to calculate the discharge of this strip, what you do is you go from this vertical d5, you go half of the width, okay, towards the right, half of the width towards the left, and this becomes our strip, okay, as you can see here. Okay, so let's say this is your vertical D, where you have taken the measurement of velocity. So you go half the way towards the right, which means another half the way you will have another measurement, the vertical, where you are measuring the next velocity, you are measuring the next velocity set. So you go from this D, you go half of the distance to right, you go half of the distance to left, and this becomes your strip, one strip. And the area of this strip is calculated as normally as we do the area, length by width. So our width is this much, right? So, and our depth is whatever D is recorded, so that becomes your area. This much is your area, right? And then further you multiply it by velocity. So velocity is average of 0.2d and 0.8d, and here we have, this is the area and this is the velocity. So q, so I, let me put it as I, is equal to area times velocity. So that this step is followed for all the section except for last two end strips. Okay, the way of calculating at the end strips are different. So here, let me explain this. Okay, so this is the last strip that you have, last vertical that you have chosen to do the velocity measurement. So usually the depth is not so large that usually only one velocity is measured, but here I have shown two. No problem, it does not matter even if there are three there are no, it's not an issue. So what we do is, the last strip we take the full right hand side, okay, or the edge that is connecting with the edge of the you can consider this as in the edge. So you take the full edge and only the half of this portion is taken, and then this becomes our strip. Okay, so this becomes our strip like it's shown here. So last strip, after the last vertical, all the distance is taken, wn, and only half of the left hand side is taken. So this becomes a triangular kind of a shape, and the width, the average width, is calculated by this formula. Okay, it's kind of unique. So average formula is given by wn plus 0.5 of wn minus 1, which is this half. Another could be here, right? Another d where you have done the velocity measurement is here, halfway from this point. So this whole thing square divided by 2wn. So this is the average width. Okay, so average width is this one, and depth, you simply take this dn as the depth. Okay, so where you have done the measurement, times the average velocity. Now here average velocity is, if there is only one point measured at 0.6d, then you take that one. Usually it is very shallow, and usually only one point is taken. So if it is 2 points are taken, like in this case, okay, so you can use velocity at 0.2 d plus velocity at 0.8 d divided by 2 instead of 1. So that's how the edge sections are, the velocity, the discharge at the edge strips are calculated, and for the rest of the strips we use this method. And then the total discharge is summation of all the QIs. So that's how we calculate the discharge using midsection. Okay, now in mean section method, what we do is, now this is one vertical. Let me take d4 and d5. These are the two verticals where you have done the measurement, right? In the previous case, if this was the vertical on which you have done the measurement, then you would have go halfway, and then you would have chosen this as your strip. But in this case, in the mean section, you will choose the strip between two verticals on which the velocity measurements are available. So this becomes your strip. And to find the average velocity of the strip, what you do is, first you average out the velocity between these two, you average out velocity between these two, again you average out velocity between these two, and then you get the average velocity multiplied by the average of these two depth times the width is given, w5. So d for this section is going to be d4 plus d5 divided by 2. This is going to be the height times width is w5. Now this becomes your area times, first you will average out this, okay, so velocity d, okay, plus velocity, this is not d, let me put it as 4 at the fourth strips, and velocity at fifth. So this is again average divided by 2. So this is how it is calculated, the velocity, the discharge is calculated for this section. Now for the last section, the area is computed like this. Velocity, like I explained it, if it is very shallow, just take it 1. If 2 points are available, then just average out these two velocities, and then area times velocity, whatever the velocity is here, you get it. You get the discharge for the end strip, and for the rest of the strip, like I explained, you choose the strip between the two verticals on which the velocity measurements are available. You average out the velocity at one strip, you average out the velocity at another strip, again you further average out the velocity. That becomes the average velocity of this strip, and that multiplied by area. Area is, you average out the two depths multiplied by the width. So that's how we calculate the discharge at a particular strip using mean section method. So with this, let's okay, there is one class activity for you. Derive an expression to compute discharge using the mid and mean section method if velocity is available at 3 points. So you can see in my derivation, so you can see I have only used, for this equation is valid only for 2 point measurements. Now if 3 points are available, how this equation would change? Simply you will have to one more velocity component will come, right? So that derivation you are supposed to do. Okay, so I assume that you would do this. With this, let's continue and solve one numerical here. Okay, the following data were collected for a stream at a gauging station. Compute the discharge. So here you can see distance from the water surface, which means distance from one end of the water surface. So let's say this is the river, and from here distance is given. So at this particular, for instance, for the first time the distance is 3. So at the 3 meter, at this vertical height, the depth is, this height is 1.4 meter. Okay, and the velocity is recorded at 0.6 d. So 0.6 d, the velocity, in fact velocity is not recorded, the revolution is recorded, and the equation is also available for calculating our velocity. So for the first case, it's going to be 0.3 n is 12 plus 0.5. so this is what gives us the velocity. Okay, so we simply substitute the value of this revolution per second. Okay, so this is in 50 seconds, so you need to convert this unit to per second first. So in 50 seconds there are 12 revolution. In 1 second, how many revolution it will take? So that conversion you need to do it and supply the value in this equation and get the velocity. And then we use mean section and the mid section. The question does not specify anything. And here is the solution. Okay, so the total. Okay, so I want you to solve this problem. Okay, so I'll give you the answer. So okay, then let's solve this together. Okay, so in this lecture I will also be solving this, so let's solve this. So here the question is, okay, so I will just teach you how to go about, and I want you to do the calculation. So to start this question, first you draw your diagram. You start by drawing a diagram so that it becomes very convenient for us to understand what is going on. So here it is. This is let's say this is the river. Okay, at a distance of 3 meter the depth is, so at a distance of 3 meter, let me put it this way. So the depth is, let me write it here, 1.4. okay, at the distance again 3, which is here, so the depth is 6 meter, again 3 meters, right? So again 3 meters, the depth is 9, right? Yes, it's 9. No, at 3 meter the depth is not 6. It's not 6. So let me erase this. I was reading the distance. Okay, so at 3 meter the depth is 1.4. At 6 meter the depth is 3.3. so here it is 3.3. At 9 meter it is 5. Okay, so let us quickly do it. I'm going to solve for this portion, and I believe you will be able to carry forward the calculations. Okay, so let me increase the width. Okay, so here by mean section, okay, let's do it by the mean section. Number 1 is mean section. In mean section, what we do is, now the velocity for at 6 meters, the velocity is available at 2 points, so at 0.2d and 0.8d, which means velocity is available in these 2 points. And even at the 9 meters the velocity is available at 2 points. Okay, so I'm going to write this as v1, v2, v3, v4. okay, so the calculation is going to be, so let me draw this strip here. So this is going to be our strip. The velocity is available here, velocity is available here, this 4 portion the velocity is available. So discharge here is going to be, the width is 3, right? The width is 3. Here you can see 3 multiplied by, now it's going to be, first we are going to average this velocity 1 plus velocity 2 divided by 2, right? Then again velocity 3 plus velocity 4 divided by 2. This whole thing has to be divided by 2 because we are going to average everything out. So here we got the let me erase this now. Okay, so we have the So we have the width, we have the velocity, we have the width, and now we need to multiply by depth. So depth is going to be how much? 3.3 plus 5 divided by 2. So this is going to be our mean section for this. Okay, so this strip. Okay, now number 2 is going to be the mid section method. Mid section method. In this, again, I'm going to take this now. So let me take a blue color here. So if you see, we'll have to take the half, right? So let me choose this 3 meter depth. So this is depth is 3.3 meter. Now here I have to go 1.5. This side I have to go 1.5, and then my shape is going to be something like this, and this is going to be my 3.3. This is going to be my vertical depth, right? So two measurements are available at 0.6 and 0.8, right? And here what I'm going to do is I will have to calculate the average velocity. So average velocity is going to be velocity at 0.2 d plus velocity at 0.8 d divided by 2. This is the velocity, right, multiplied by the, now we have to refer to the equation so that we don't miscalculate it. Midsection and midsection method. So we simply average out the width, which means here in our case the width is going to be 3, and we simply take the depth. Okay, so here we average out the width. So average out the width means, so here is going to be 3 and here is going to be 3, so it's going to be, the width is going to be 3 after all, right? So it's going to be 3 times the depth is going to be 3.3. so this is how we calculate. This is the velocity, this is the area, and then when you multiply it, you are going to get discharge at particular section for this section. So this was for mid, and this was for mean, and this was for mid. So likewise you can continue the calculations, okay, and complete this. Okay guys, with this I would like to end this particular lecture here. Thank you.